This video introduces our new solar water pump kit. The kit includes one water pump, one pump controller, and a set of accessories. For the demonstration, we use a transparent acrylic container to simulate a water source and a plastic bucket to simulate a storage tank, showing how the solar water pump system works. First, solder the three MC4 female connectors with wires from the package to the pump's output cables and wrap them securely with insulating tape. Then solder the other pair of MC4 connectors to the positive and negative terminals of the solar panel. Male to positive, female to negative. Next, install the sensors included in the accessory kit to the sensor interface. Now let's explain the sensor installation logic and control principle. The controller uses 5 metal electrodes to detect water levels. Each electrode has the same wire length. The difference comes from the installation height. When the water level reaches a specific electrode, the water conducts electricity and completes a circuit, sending a signal to the controller. The sensor interface is divided into two sections. The first 3 terminals are for monitoring the storage tank water level, and the last 2 terminals are for monitoring the water source level. We recommend connecting the red, blue, and black sensor wires to the TL, TH, and COM1 terminals respectively. COM1 is the common terminal shared by both TL and TH. Then connect the 2 white sensor wires to the COM2 and WL terminals. COM2 works with WL to form the water source protection circuit. When installing the sensors, COM1 and COM2 should be fixed at the lowest water level of the storage tank and the water source. Fix the TL sensor at the low water level position of the storage tank. When the tank level drops below TL, the circuit between COM1 and TL opens. Once detected, the controller will start the pump and begin filling the tank. Fix the TH sensor at a high water level position. When the water rises and touches the TH sensor, the circuit between COM1 and TH is completed through the water. The controller detects this and immediately stops the pump to prevent overflow. Fix the WL sensors above the COM2 sensor in the water source. WL serves as a dry run protection point. When the source water level falls to WL and the circuit between the COM2 and WL opens, the controller identifies this as a lock of water and locks the pump to prevent dry run and potential damage. Now that we understand the logic, let's go back to the wiring. Connect the 5 sensors to their designated terminals. If your water source is a river, lake, large reservoir, or a stable municipal supply, sources that normally do not run dry, the dry run protection is not necessary. In this case, you may simply short COM2 and WL. Then mount the sources at appropriate water levels in both the storage tank and the water source. Next, connect the pumps W, V, and U 3-phase wires, followed by the PV positive and negative wires. Always check the phase order and polarities. Make sure to connect the pump first before connecting the breaker's output to avoid exposing the controller to high PV open circuit voltage with no load. We recommend installing a breaker on the PV line. After all wiring is completed and confirmed, close the PV breaker to power the controller. In this demonstration, we use a DC power supply to simulate a PV input. Once connected, the controller will start automatically. When stable PV input is detected, the controller will run the pump according to the sensor signals. The buttons from left to right are decrease pump speed, start or stop the pump, and increase pump speed. Finally, let's observe the control effect. When a storage tank reaches the TH level, the pump stops. When a water source drops to double L level, the pump also stops.